Hello and welcome to the classes by Mrs. Monisha Nath Paul. Today we are back again with the topic congruence of triangles. Last day we had discussed about the various rules on congruence of triangles. Today we shall do sums based on those rules. If you have not gone through the previous videos of this topic, then you have to go through. Otherwise, these sums will become a little difficult for you to understand. So if you want to understand these sums clearly, then you have to go through the previous videos, the links of which has been mentioned in the description box. So you can see already there are two sums here mentioned on the board. We shall start with the first sum. The first sum says ABCD is a quadrilateral in which AB is equal to BC and AD is equal to CD. So you can see I have drawn the figure already for you. So it's a quadrilateral in which ABCD is the four vertices, and it is given to you that AB is equal to BC and AD is equal to CD. We have to show that BD bisects both the angles ABC, that means bisects this angle, so BD and angle ADC. So that means we have to make a construction by joining BD. So here we have done a construction. What is the construction that we have done? B and D are joined. Okay. So the given part, what are the given parts here? AB is equal to BC. AD is equal to CD. These are the given parts. And we have to show, to prove part is what? The to prove part, we have to prove that is BD bisects angle ABC and angle ADC. All right. So you can see when I had constructed this line BD, line segment BD, I have got two triangles here, triangle 1 and triangle 2. Now imagine this is a piece of paper and I try to fold the paper along the line segment BD. So what are the things that you can see while after you fold the paper? You will see the side BC and the side BA will overlap each other, and the side AD and CD will again overlap each other. That means if I fold this second triangle over the first triangle, we are going to get one such triangle, which is means the second triangle and the first triangle are replicas of each other. Once we superpose the second triangle on the first or the first triangle on the second, we are getting one single triangle. That means the first triangle is exactly covering the second triangle. So the first triangle is going to be congruent with the second triangle. Alright, so this much is clear for us. Now the very important thing while writing about congruency or writing about congruent triangles is the matching of the vertices. So I have discussed in the last class also that how do we name triangles. Say for the first triangle, for the triangle 1, what are the vertices? A, B and D. Okay, A, B and D. Now when you are folding the second triangle over the first triangle, you can see the vertex C and the vertex A will coincide. So this and this will coincide. B will coincide with the B itself and D will coincide with D. Also, so once you start to prove, the proof part happens in this way. When you're proving it, so you have the statements this side and the reasons this side. So in, what are the two triangles that you're going to choose? In triangle ABD and triangle CBD. So I have kept the first triangle on the left hand side, the second triangle on the right hand side. So once I am giving the statements for it, we will make sure whatever sides or angles, whatever it is that we are including here, we will put for the first, we'll put the measure, the angles and the sides of the first triangle on the left hand side and for this on the right hand side. So the first reason is, what are the things that we are going to check here for the congruency. You can see that this side x and x is same, y and y is same, and this side BD is common to both the triangles. Alright, so we can see that all the three sides of both the triangles are equal. That means the two triangles are going to be congruent using the rule side, 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 because the three sides of this triangle and the three sides of this triangle both are equal in their measure. So AB is equal to CB. Now it is given AB is equal to BC. I said you always try putting your reasons, keeping the matching in your mind, matching of the vertices in your mind. So when I say AB, we'll say CB. Though it is given BC, we know line segment BC and line segment CB are same. So AB is equal to CB. So when you keep writing in this way, it becomes easier for you to locate. See, AB is equal to CB. Alright. So what is the reason for this? This is given to us already. Number 2, AD is equal to CD. See, check it out. AD, CD. Alright. This is also given to us. Third, BD equals to BD, because BD is a common side to both the triangles. So you can see over here BD and BD is same. So BD is equal to BD. This is the common side. Alright. So we can see that, see, this is a side, this is again a side, again a side. So therefore triangle ABD is congruent to triangle CBD by which rule? By side, side, side rule of congruence. The congruency part is done. Next is this. We have to show that BD bisects angle ABC. So which is angle ABC? ABC. That means we have to show this line segment BD is bisecting this ABC in two equal parts, also bisecting ADC in two equal parts. So here, how we are going to prove this? Coming here, check. So because these two triangles are congruent, so with three sides we have proved that two triangles are congruent. That means the corresponding three angles have to be same because the triangles are congruent. So we know that for congruent triangles, the corresponding paths are equal. So for when we have proved the congruency of the two triangles, that means the three angles have to be, the corresponding three angles again are equal. So here we can say that ABD, angle ABD is equal to angle CBD. Reason? CP, CT. Also, that is implying what? This implies BD bisects. So ABD and CBD are equal. That means BD is bisecting ABC. So this part is done. Secondly, ADB is equal to CDB. Okay, ADB is equal to CDB. This is representing that ADC is bisected in two equal parts, this and this, by BD. That means BD bisects angle ABC. So we have proved. So we can cite thus BD bisects both angle ABC and angle this is ABC and this is ADC. Okay, ADC. Hence proved. Alright. I hope this sum is clear to you. First we did a construction. The figure was, even if the figure is given to you in the question, good for you. If it is not, still you can make the figure on your own. Quite a clear question here. That is, these two adjacent sides, that is AB and BC are equal. Here AD and CD are equal. That much is given to you in the question. And we had to show the angles ABD and ADC are bisected by the line segment BD. So once you draw the figure, you have to make a construction. What is the construction? That is, B and D are joined. Okay. So once BD is joined, we are getting a line segment here. So we have to prove. For proving this, we have to check the congruency. Congruency of what? Congruency of these two triangles that have been formed by drawing this line segment BD. When we drew the line segment BD, we got the figure split up into two triangles. Triangles ABD and triangle CBD. So we will prove the congruence of these two triangles. So you can see that AB is equal to CB. I said naming of the, put the vertices in the proper order, so that while you are writing the statements also, if you use that same order, it becomes easier for you to cross check. So AB is equal to CB. That is one of the conditions. Second is AD is one of the statements. Second is AD is equal to CD. Second one. Third is BD. BD is a common side to both the triangles. That means you see three sides of this triangle and three sides, the corresponding three sides of the second triangle are all equal. That okay. I hope this is clear. Now we shall move on to the second question. The second question says that AB is a line segment. Okay, we shall draw the figure. So AB is a line segment and L is its perpendicular bisector. So we know a perpendicular bisector is a line that is drawn in such a way which is perpendicular to the line segment and will bisect the line segment in two equal halves. Okay. Now P is a point on L. So let us consider P is a point here on L. P is a point on L. We have to show that P is equidistant from A and B. So let us join this. So P is a point. You have to show that P is equidistant. That means PA is equal to PP. This is what you have to prove. So your proving part is PA is equal to PV. This is what we are asked to prove here in this sum. So what are the things given to us? In the question we are given that line L, this is the line L. Line L is the perpendicular bisector of AB and P is a point on L. Alright. And it is, let us assume it is bisecting the line segment AB at M. Alright. So we can say that MP is perpendicular to AB. So if I consider the triangles 1 and 2, this is the two triangles that have been formed. Let us now, I'll draw this as a proper line. So if I fold the second triangle on the first, what you can observe? That is, this side and this side will flap each other, overlap. This one will overlap on this and this is the common. So to prove, we require certain things. What is the rule that we are going to use here to prove the congruence? Let us see. First, because this line L, it is the perpendicular bisector. That means what are the things given to us? AM is equal to BM. Alright. Next, you see the 90 degree. This is 90, this is 90. So we have one angle over here. Both are 90. And this is MP or PM. It is common to both the triangles. So when you are trying to prove the congruency, what is the way we will consider the triangles? So in triangle APM and triangle BPM. Naming, be very careful. When you are covering this on this, you'll see the M of the first triangle and M of second triangle lie at the same place. P of the first triangle, P of second triangle lie at the same place, and A and B will lie at the same place. Okay, so A and B, P and P, M and M. Alright, the naming of the vertices, the naming of the triangles are done matching the vertices. So the first thing that you will write here is, first, AM equals to BM. What is the reason for AM is equal to BM? That is because L is the perpendicular bisector of the line segment AB. So we can say that M is the midpoint of AB. Okay, because L bisects the line segment AB. So M is the perpendicular, M is the midpoint at which the line segment bisects AB. So midpoint means AM will be equal to BM. That is, it is breaking the line or splitting the line in two equal parts. Second, we have a angle between them. That is the 90 degree. So angle so we can say angle PMA is equal to angle PMB. That is equal to 90 degree. Both of them is equal to 90 degree. Why? Because we can say that PM is perpendicular to AB. Okay. Alright, each is equal to 90 because PM is perpendicular to, because this line segment is perpendicular, that means PM is a part of this line segment. So PM is also perpendicular to AB. Next, PM equals to PM. What is the reason? Common side. So we can see that the triangle APM and the triangle BPM both are congruent to each other. And what is the rule that we have used? See, side, angle, side. One side, an angle and a side. So side, angle, side rule. Therefore, triangle APM is congruent to triangle BPM by SAS rule of congruence. So the two triangles have been proved. It is APM and triangle BPM. APM and BPM have been proved to be congruent. And by what rule we have established their congruence? By using the side angle side rule. Now we have to prove what? PA is equal to PB. So PA is equal to PB. What is the reason? PA and PB are what? They are the congruent parts. So congruent parts, they are the corresponding parts. So corresponding parts of the congruent triangle. So we know that they have to be of equal measure. What is the reason for that? CP, CT. That means we can write thus. See, P is a point equidistant from A and B. So we can say thus, going by the question, P is equidistant from A and B. Hence, proved. So this sum was based on the rule SAS. So what was the question? The question was AB is a line segment and we have a line L which is the perpendicular bisector. Everybody knows what is a perpendicular bisector. Perpendicular bisector breaks a line segment into two equal parts and intersects it at a right angle. Okay. So L was a perpendicular bisector. Now say P is any point on the line. So P we have considered a point on the line. We have to show that this point P is equidistant from the two points A and B. So let us assume that M is a point on the line segment AB where the line L has intersected the line segment AB. So M is lying on this line and it is meeting the line segment AB. So M is the midpoint, because here L is the like perpendicular bisector. So let us assume that M is the point at which the bisection has taken place. So AM is equal to BM. So from here, this much we can understand that this is given to us. And also PMA and PMB are 90 degree. As by this figure, you can see that this has to be the right angles. So if we consider what is the way of choosing the vertices that we are going to write in the order so that the two triangles are proved to be congruent, you try to fold the figure. By folding, you can see that this side will fall on this side. Okay. This angle and this angle, they are same, and this is the common side. So by which axiom? So see, side, angle, side axiom. So AM is equal to BM. That is one of the statements. That is, M is the midpoint. So AM is equal to BM. Next, PMA and PMB, they are 90 degree. Reason? Because it is the perpendicular bisector, means it is the perpendiculars here that has been formed 90 degrees. So PM is perpendicular to AB, because L is perpendicular to AB. So naturally PM is perpendicular to AB. So PMA and PMB, they are 90 degree each. Okay. Next is PM is equal to PM, because PM is a common side to both the triangles. So it's a common side. So you can see side, angle, side. Always try to write in the order of the rule that you are using to prove the congruence. Make sure you are trying to write it in that order, so it becomes easier for you. Okay, so I've written side, angle, side. You can write this common side in the first place and this AM and BM in the second place. No harm. That you can interchange, but second place should be taken up by the angle only. So side, angle, side rule has been established here. So we can say PA is equal to PB. Now this was what we had to prove here. That is, P is equidistant from A and B. So from A and B, P is equidistant means we have to show this length and this length. That is, PA length and PB length are equal. So PA and PB are what? They are the corresponding parts of these two triangles. And we know that for congruent triangles, the corresponding parts are always equal. So since we have established the congruence, we can say that these two, which are the congruent, the corresponding parts, they are also equal by stating the reason CPCT. It is corresponding parts of congruent triangles. Thus, we can say this only in form of statement. We can say that P is equidistant from A and B, and hence proved. Okay, so these were the two sums based on side, side, side and side, angle, side. Please go through the video so that the two topics, side, side, side and side, angle, side, become clear to you. Also, sums based on the other rules will be coming up in the next videos. We'll meet you soon in the next videos. But don't forget, if you like the videos, if you like the sums, and if you like the explanation, do like the channel. Also comment your doubts, your questions, so that I can help you in solving your queries and come up with topics that are of your interest. And don't forget to subscribe the channel. Thank you and meet you soon.